This lesson discusses the use of sensitivity analyses in Cochrane diagnostic test accuracy reviews. Sensitivity analyses need to be planned when developing a protocol. They are undertaken when analysing and presenting results, and they impact on the interpretations and conclusions which can be drawn from the Cochrane review. The learning objectives for this lesson are to understand what sensitivity analyses are and how they are undertaken, to be able to appropriately plan and undertake them and understand their implications on review conclusions, and to understand the differences between sensitivity analyses and subgroup analyses, as these are often confused in protocols and reviews. In this session I will first explain what sensitivity analyses are and why they are undertaken, and explore the issues in a review which they can investigate. I will then present some examples illustrating where sensitivity analyses may be useful. Finally, we will look at the differences and similarities between sensitivity analyses and subgroup analyses. So what is a sensitivity analysis? A sensitivity analysis involves repeating the primary analysis, usually a meta-analysis, but doing so with changes to the data. This may be, for example, changes to the numbers from results of individual studies, or changes to the studies which are included in the analysis. Sensitivity analysis may also be undertaken comparing different ways of undertaking meta-analysis. So what is the aim of undertaking a sensitivity analysis? Sensitivity analyses are used to investigate whether the findings of a review are dependent on decisions made during the review process. Some decisions are necessarily arbitrary. For example, when nominating a threshold value to define the age of elderly people. They may be controversial, for example in the choice of a particular reference standard, and sometimes they are dubious or unclear, simply because of poor reporting of methods in the primary research studies. Occasionally, data included in the primary studies may be somewhat unclear, and sensitivity analyses are used to investigate the impact of the uncertainties in the results. If, when we undertake a sensitivity analysis, it shows that the findings are not dependent on these decisions and uncertainties in the data, we can safely conclude that the results of the review are robust. This provides us with confidence in the findings, as they have been shown not to be overly dependent on the decisions made during the review process. If, however, the sensitivity analyses indicate that the findings are sensitive to some of these decisions and uncertainties, one of several lines of action may be taken. First, it may be possible to reduce uncertainties by deploying greater resources. For example, if an aspect or result of a study is omitted or unclear in the research paper, corresponding with the author may provide clarity and remove that uncertainty. If the uncertainties cannot be resolved, this means that the results of the review do depend on these dubious, uncertain, or arbitrary decisions, and the results must be interpreted with appropriate caution. A review may point out, in its recommendations for further research, what future researchers need to be doing to design and execute studies to provide a clearer answer. The protocol for a Cochrane review should, as far as possible, describe the sensitivity analyses which will be undertaken. Sometimes it is possible to anticipate sensitivity analyses. For example, if it is known that studies may have used a mixture of reference standards, some less accurate than others, you may decide to pre-plan a sensitivity analysis for your review that restricts included studies only to those which use the most certain reference standard. However, many sensitivity analyses cannot be anticipated and are identified as being of importance during the review process. So let us consider the sort of issues which might be investigated by sensitivity analyses. It is helpful to look at the framework for the review process and identify steps where these may arise. Many of these issues arise during the definition and application of eligibility criteria. First, for the methodological eligibility criteria, often it is stated that both cohort and case control studies will be included in a Cochrane DTA review. You may then wish to plan a sensitivity analysis excluding the case control studies, which are at higher risk of bias, from the review. And when a review is making comparisons between tests, it is wise to plan a sensitivity analysis that restricts the data included to only those studies designed to compare the tests. In the patients and setting eligibility criteria, we often discover that the studies do not neatly fit. For example, it may be that patients should be symptomatic, but some studies may include a small fraction of asymptomatic patients. Should such studies be excluded? Or maybe the study is looking at the use of a test in adults, and some studies include a small number of children. Where the proportion of ineligibles is small, often review authors decide to include these studies in the main analysis, but a sensitivity analysis is planned to investigate the impact of their exclusion. Another example is where some studies are not done in the same setting as the review question. Often there are variations of generation, type and brand of index test, and questions arise as to whether all brands and all tests should be included, or whether the analysis should be restricted to currently available, more recent brands. Some tests require different levels of quality control and training, and it may be that a sensitivity analysis is thought important to investigate the impact of restricting inclusion of studies to those with the most stringent training and quality control processes. Sometimes assays are available both in commercial forms and as research or in-house assays, and sensitivity investigations may be done to investigate whether they are making any differences to the results. Finally, the eligibility criteria for defining reference standards and target conditions may be a source of planned sensitivity analyses. For example, it may be known that the definition of the target condition varies between studies, or reference standards may be based on different combinations of tests, some of which are thought to be more reliable than others. Or reference standards sometimes involve following patients to ensure they remain free of disease. The length of time for follow-up can be investigated. Often longer times lead to more complete ascertainment, but risk inclusion of incidental cases. Sensitivity analyses can be planned to investigate all of these. Moving on to searching. Occasionally when we are searching, we may be finding unpublished studies and abstracts which provide less detail about the study. It may be important to undertake a sensitivity analysis to investigate the impact of including such non-peer-reviewed results in a Cochrane review. When we collect data, we may find in some reviews that data are presented as patient-level data in some studies and based on body parts, whether they are eyes, limbs or lesions in others. Comparison of analyses based on only patient-level data with an analysis using all data may be important. And often tests are not presented as binary results but have intermediate categories. It may not be clear whether the intermediates should be categorized with the positives, with the negatives, or dropped. Sensitivity analysis can be used to see whether these different approaches matter. And finally, there are opportunities to investigate whether the meta-analytical methods used make a difference to the findings through using sensitivity analyses. For example, some meta-analytical models can be simplified to assume a common shape for all summary ROC curves, or assumptions can be made that the random effects are of the same magnitude for all tests. The importance of these simplifying assumptions can be investigated. Let us now look at two published examples of sensitivity analyses from Cochrane DTA reviews. Our first example concerns a review of cardiac function tests in patients considered for kidney transplantation. The target condition in this review was defined in different ways in the different studies. The optimum reference standard for severe stenosis was determined as being a measurement of greater than 70% stenosis made by using coronary angiography. However, several studies used a lower threshold of 50% to define severe stenosis, and others were noted to be at risk of partial verification bias, as only a subset of patients underwent coronary angiography, that selection being based in part on the results of the index test. The main comparison in this review is between dobutamine stress echocardiography, DSE for short, and myocardial perfusion scintigraphy, or MPS. The authors reported sensitivity analyses in the text of the review. Here I have brought them together in a table. The main analysis is shown in the top row, based on all data, and shows a significant difference in accuracy, DSE being both more sensitive and notably more specific than MPS. 3 sensitivity analyses were then undertaken. The first removed studies which had used the 50% threshold for stenosis. The second removed studies at risk of partial verification bias, and the final removed studies failing on one or either or both of those criteria. In all 3 sensitivity analyses, the ranking of the studies remained consistent, with DSE outperforming MPS in both terms of sensitivity and specificity. However, the statistical significance and the magnitude of the differences decreased across the sensitivity analyses, the difference in specificity becoming notably smaller. Thus, the sensitivity analyses raise concerns that it is not possible from this data to draw strong conclusions that DSE outperforms MPS. The second example concerns screening for Down syndrome. This is one of a suite of reviews being published in the Cochrane Library on this topic. The participants in this review are pregnant women who underwent testing using blood tests at around 20 weeks gestation. The apparently novel finding of this review was that the sensitivity of these tests appeared to be lower in studies which restricted recruitment to older mothers, defined as those aged 35 and above. Of concern is a risk of bias in these studies arising from the use of different reference standards in the different studies. Some studies used amniocentesis to karyotype all fetuses at 20 weeks, whereas other studies only karyotyped a subset of fetuses, those found at high risk by the index tests, and used birth outcomes as the reference standard for the remainder. The bias this would cause arises because of the loss of women through miscarriage in those followed up to birth. The 2x2 table here contains artificial data to illustrate the potential bias. In studies which use amniocentesis in all women, no woman will be lost to follow-up, and here the sensitivity and specificity, defined as 50% and 95%, would be observed in the data which were analysed. However, if the same set of patients went into a study in which amniocentesis was used in those with a test risk positive for high-risk use, and birth outcomes were used to define the reference standard for those with low risk, there will be a loss of some women from the study in the birth outcomes through miscarriage, which occurs between 20 weeks and full gestation. The table might look something like this. We are presuming a loss of 16 and a loss of 237 from the two groups. Of importance here is to note that the loss to follow-up may be higher in the Downs than in the normals, because miscarriage is more common in Downs pregnancies than in normal pregnancies. The impact in this case here is that the sensitivity is overestimated at 60% rather than 50%, and this occurs through only losing 5% of the patients to follow-up. The review authors undertook a sensitivity analysis to investigate whether dropouts from miscarriage could explain the apparent difference between the age groups. The studies done in older mothers tended to be the ones in which amniocentesis was used in all pregnancies. The sensitivity analysis inflated false negative numbers in the 2x2 tables for the studies which had differential verification to account for potential loss through miscarriage. The results presented here are for the three combinations of markers, showing the sensitivity in the group of over 35s compared with the group of younger mothers. In these original results with no false negative corrections, the differences in sensitivity between the age groups are evident and statistically significant for two of the three tests. When the numbers of false negatives were increased by 10% in a sensitivity analysis, the test sensitivity in the younger mothers decreased. This decrease continues as the inflation in false negatives was increased further. Once the false negatives are increased by 50%, the statistical significance of the difference for the first test disappears as the sensitivities have become much closer. This review concluded, through this use of sensitivity analysis, that the apparently novel finding of a difference in test accuracy by age group can partially, but not totally, be explained by the potential different miscarriage rates experienced in those verified by follow-up. This is a particularly complex illustration of the use of sensitivity analysis, but it illustrates its ability to investigate deficiencies in study designs. Now let us consider the differences between sensitivity analyses and subgroup analyses, as these are often confused. In a sensitivity analysis, we restrict the analysis to a subset of the totality of the studies. You might like to call this a subgroup, but that is where the confusion can start to arise. The focus of a sensitivity analysis is on comparing results in this subset with the result of all studies included in the primary analysis. We do not use a statistical method to make this comparison, it is done informally. And the purpose of doing this is to address a question of whether the overall primary analysis, including data from the original studies, is valid. Subgroup analyses divide studies into mutually exclusive and exhaustive subgroups, and initially estimate the performance of the test in each subgroup. The subgroups are defined by some characteristic from the studies, maybe the participants, the tests, or study methodology. The focus in the analysis is on the comparison of accuracy between the subgroups, which can be done formally using meta-regression to estimate the relationship and test its statistical significance. Its purpose is to assess whether that particular characteristic is related to test accuracy. Thus, the purpose and focus of these two different types of analyses are quite different. Sensitivity analyses and subgroup analyses may both be undertaken to investigate the same characteristic. Consider the example here from a DTA review published in the Annals of Internal Medicine, which consider the accuracy of rapid influenza diagnostic tests. A question which arose in this review was whether the studies funded by industry had different findings from those without industry involvement. If we address this question as a sensitivity analysis, our focus is on looking whether including commercially funded studies makes a difference to the overall findings of the review. There were 119 studies in total, 96 of which did not have commercial sponsorship. Looking at the findings in the table, you can see there's a very slight increase in sensitivity from including industry-funded studies, but little difference in specificity. The authors reasonably concluded from this analysis that the little difference that inclusion of the industry-funded studies makes means that the primary analysis, including all studies, is probably valid. However, if we approach this as a subgroup analysis, our focus shifts to the question of the relationship between test accuracy and commercial funding. This analysis requires us to divide the total set of studies into two subgroups. It is now clear that the studies with commercial funding had a higher sensitivity than those without. The specificity differed little. The conclusion from this analysis is that there is a statistically significant relationship between commercial sponsorship and reported test accuracy, the sensitivity being significantly higher. Thus, for this example, there are apparent conflicts between the results of a sensitivity analysis, which shows quite clearly that including the commercially funded studies makes little difference to the overall estimates, mainly because they are the minority, whilst noting that there is a statistically significant relationship between funding and results. The take-home message from this lesson is then that we have seen that sensitivity analyses investigate whether review findings are robust to decisions made during the review process and the uncertainties in the data. We have considered many different examples where this could occur. We noted that some sensitivity analyses can be planned and detailed in the protocol, but many are identified during the review process and may be idiosyncratic to the clinical scenario, the test used, and the studies that have been identified. And finally, sensitivity analyses and subgroup analyses are different and are undertaken for different purposes using different methods and answer different questions. Occasionally, they can draw apparently conflicting conclusions.